October 12, 1941. The proving grounds outside Berlin lay shrouded in morning mist as a captured Soviet tank sat motionless on the firing range, its angular hull catching the pale autumn light. Dr. Friedrich Werner, chief metallurgist at the weapons testing facility, stood with his clipboard, utterly confident that within hours they would decode the secrets of this primitive Soviet design and dismiss it as yet another crude product of an inferior industrial system. He had no idea that by day's end, every assumption he held about German technological supremacy would lie shattered at his feet, like the fragments of their own shells. Before we dive into this story, make sure to subscribe to the channel and tell me in the comments where you're watching from. It really helps support the channel. What unfolded that day would force Germany's finest engineers to confront an uncomfortable truth. That innovation sometimes emerged not from precision and sophistication, but from brilliant simplicity born of desperate necessity. Werner adjusted his glasses as he examined the Soviet tank before him. The T-34 medium tank had been captured intact near Smolensk 3 months earlier, transported by rail across occupied territory, and delivered to the facility with the urgency typically reserved for wonder weapons. Standing beside him was Oberst Hans Guderian, no relation to the famous general, but equally demanding in his expectations, representing the High Command's urgent need for answers. The tank appeared almost crude in construction compared to German standards. Welding seams showed irregularities that would never pass German quality control. The finish was rough, almost agricultural in its simplicity. Werner had examined hundreds of captured vehicles throughout his career, from French tanks to British designs, and none had caused the alarm that reports from the Eastern Front now generated about this particular machine. Colonel Guderian tapped the armor plate with his riding crop. "Herr Doctor, our forces report that standard anti-tank rounds are ineffective against these machines. Field commanders describe shells bouncing off like pebbles. We need to understand why." Werner permitted himself a thin smile. "Colonel, field reports are notoriously unreliable. Combat stress, poor visibility, inadequate training in target identification. I suspect we will find this armor is simply thicker than expected, nothing more. Soviet metallurgy is known to be primitive." 3 junior metallurgists stood nearby with testing equipment. Heinrich Vogel, barely 26 years old but already published in materials science journals, Klaus Richter, a veteran of armor testing who had examined every German tank design since 1935, and Martin Hoffmann, whose specialty was crystallography and metal stress analysis. They had prepared a comprehensive testing protocol that would subject the Soviet armor to every standard evaluation in their repertoire. "We begin with measurement," Werner announced, approaching the tank with calipers. The hull armor measured at various points, the readings carefully recorded. 45 millimeters on the frontal glacis, sloped at an angle of 60 degrees from vertical. The turret face measured 52 millimeters. Vogel did quick calculations on his notepad. The sloping effectively increases protection to approximately 80 millimeters equivalent against perpendicular impact. That is significant, but our 50 millimeter PaK-38 should still penetrate at combat ranges. "Should," Richter repeated, his tone skeptical. He had been reading the field reports more carefully than his colleagues. Yet crews report firing at ranges of less than 300 meters with no penetration. Multiple hits, no effect. Werner waved dismissively. "We shall see. Prepare the first test firing." The testing range had been set up with meticulous German precision. Air-captured Soviet 76.2 millimeter tank gun sat mounted on a test stand at a distance of 500 meters, aimed directly at the T-34's hull. This gun, removed from another captured tank, would serve as their baseline. If Soviet shells could penetrate Soviet armor, they would understand the specifications that Soviet designers had worked within. The first round loaded. Werner gave the signal. The gun fired with a sharp crack that echoed across the grounds. The shell struck the glacis plate dead center with a sound like a massive hammer blow. But instead of penetration, there was a brilliant flash of sparks and the shell careened away, spinning end over end across the testing ground before burying itself in the earthen backstop 200 meters beyond the target. Werner blinked. Vogel stood with his mouth open. Richter slowly set down his clipboard. "Load another round," Werner said quietly. The second shot struck almost exactly where the first had. Again the deflection. Again the shower of sparks and the whine of ricocheting metal. The armor plate showed only a slight scoring where the shells had struck. "Impossible," Vogel whispered. "The mathematics do not support this outcome." Werner approached the tank, running his hand over the impact points. The metal was barely scarred. He had seen thicker armor defeated by lesser guns. This made no sense according to everything he understood about ballistics and metallurgy. "Bring up the Pak-38, he ordered. The 50mm anti-tank gun was German-made, a standard weapon deployed across the Eastern Front. Crew efficiency ratings showed experienced gunners could fire up to 15 rounds per minute under optimal conditions. This was the weapon that field reports claimed was ineffective against the T-34, a claim Werner had dismissed as impossible. They positioned the gun at 300 meters, a typical combat engagement distance. Werner himself checked the alignment, ensuring the shot would strike perpendicular to the sloped armor, the most favorable angle for penetration. The gun fired. The shell struck with tremendous force and bounced away. Colonel Guderian's face had gone pale. Fire again. Over the next hour, they fired 17 rounds from the Pak-38. 3 different ranges, 300 meters, 400 meters, and at one point simply 200 meters. Every angle they could achieve within the limitations of the gun's traverse. The results were consistent and horrifying. The shells either bounced off completely or, in 2 cases, shattered against the armor without penetrating. Werner examined each impact point with a magnifying glass. The armor showed dents, scoring, stress marks, but no penetration. In several places, fragments of German shells were embedded in the Soviet armor, but the steel had not failed. "I need samples," Werner said. His voice had lost its earlier confidence. "We must cut sections from this armor and examine the metallurgical structure." The cutting took 3 hours. Industrial saws screamed as they carved through the Soviet steel. Werner himself supervised the extraction of a 10-centimeter square sample from a section adjacent to an impact point. The sample would undergo every test they could devise: hardness testing, tensile strength analysis, microscopic examination of the grain structure, chemical composition analysis. While the cutting proceeded, Richter examined the tank's other features: the wide tracks, each link weighing several kilograms, the Christie suspension system with its large road wheels, the diesel engine, unusual in tanks of this era when most nations used gasoline, the sloped armor on all sides, not just the front. "This entire design philosophy is different from ours," Richter observed. "Look at the simplicity. The turret hatch is crude, barely finished. The periscopes are basic. The gun sight appears almost primitive. Yet the fundamental engineering, the weight distribution, the armor geometry, it is brilliant in its simplicity." Hoffman had been examining the interior through the open hatches. "The crew space is minimal. A German crew would find this unbearably cramped. There is no provision for comfort whatsoever. Radio equipment is basic, sometimes absent entirely in early models according to intelligence reports. This tank is designed purely as a fighting machine with no concessions to crew welfare." Werner barely heard them. He was staring at the armor sample in his hands as if it were an artifact from another planet. "Tomorrow, we conduct the full metallurgical analysis. Tonight, I must review everything we know about Soviet steel production." The laboratory analysis began at dawn on October 13th. Werner had not slept. He had spent the night reviewing captured Soviet industrial reports, intelligence assessments of factory capabilities, anything that might explain what he had witnessed. The first test was Brinell hardness testing, a standard measure of steel resistance to deformation. Vogel carefully positioned the sample under the testing apparatus, applied the standard load, and measured the resulting indentation. 280 on the Brinell scale, Vogel announced. "That is extraordinarily hard for armor plate. Our own face-hardened armor rarely exceeds 260. "Test multiple points," Werner instructed. "I want to know if this hardness is uniform or if they are simply surface hardening the steel." Multiple tests showed the hardness was consistent throughout the sample thickness. This was through hardened armor, not face-hardened. The implications were significant. Face-hardened armor, used by Germany and most other nations, created a hard outer layer to shatter shells while maintaining a tough inner layer to prevent cracking. Through hardening was simpler, but typically resulted in brittle armor that could crack under impact. Except this armor had not cracked. It had absorbed 17 direct hits without failing. Hoffman prepared the sample for microscopic examination, carefully polishing and etching the steel to reveal its internal structure. Under the metallurgical microscope, the grain structure became visible. "Herr Doctor, you must see this." Werner peered through the eyepiece. The crystalline structure of the steel was extraordinarily fine and uniform. He had expected the coarse grain structure typical of rapidly produced steel, the kind of metallurgy that resulted when production quotas were prioritized over quality. Instead, he saw a structure that indicated careful alloying and controlled cooling. "This is not crude steel," Werner said slowly. "This is sophisticated metallurgy disguised by crude finishing." The chemical analysis took longer, requiring careful spectroscopic work to identify every element in the alloy. By midday, they had results that Werner read with growing disbelief. The Soviet armor was alloyed steel containing significant chromium, nickel, and molybdenum. These were expensive alloying elements, difficult to obtain and challenging to work with. The percentages were different from German armor specifications, but the fundamental approach was equally sophisticated. "Where are they obtaining these alloys?" Colonel Guderian demanded when Werner reported the findings. "Intelligence reports indicate their industrial capacity is primitive, their workers untrained, their factories evacuated and disrupted by our advances." Werner spread the test results across his desk. "Colonel, I believe we have fundamentally misunderstood Soviet industrial capabilities. This armor represents advanced metallurgical knowledge. The alloy composition is different from our specifications, but it is not inferior. In some respects, it may be superior." Vogel had been performing calculations based on the sloping angle and the measured hardness. "Herr Doctor, I believe I understand part of the puzzle. The sloping is not merely an aesthetic choice or a way to increase effective thickness. At 60 degrees from vertical, and given the extreme hardness of this steel, the armor creates an optimal condition for shell deflection. Our shells are striking a surface that combines hardness, slope, and toughness in a way that maximizes the probability of ricochet." "Show me the mathematics," Werner demanded. Over the next hour, Vogel demonstrated how the combination of factors created what amounted to a nearly perfect defense against the current generation of German anti-tank weapons. The slope meant shells struck at an oblique angle. The hardness meant shells could not dig in and normalize their trajectory. The toughness meant the armor did not crack even under repeated impacts. "The Soviets have solved the armor equation differently than we have," Werner concluded. "We prioritized workability and reliability. We created armor that could be manufactured to tight tolerances, that could be welded precisely, that met our standards for finish and appearance. They prioritized effectiveness above all else. They created armor that works, even if it looks crude." Richter had been examining intelligence reports on Soviet tank production. According to captured documents, they are manufacturing these tanks at a rate of more than 1,000 per month. The factories at Kharkov, Stalingrad, and the Urals are producing them faster than we can manufacture our own designs. "That cannot be accurate," Colonel Guderian protested. "Such production rates would require enormous industrial capacity and skilled workforce." "Unless," Werner said slowly, "the design is deliberately simplified to enable rapid production. Look at this tank again, Colonel. The crude welding that we interpreted as poor quality, what if it is deliberately expedient welding? Good enough to hold, fast to execute. The rough finish that offended our sensibilities, what if it saves hours of grinding and polishing time per vehicle? The simple gun sight and basic radio, what if those represent a conscious decision to prioritize production speed over refinement?" The implications settled over the room like a cold fog. Germany had spent years developing sophisticated tank designs with precision engineering, tight tolerances, complex systems. Each tank was a masterpiece of German engineering, taking weeks or months to produce with skilled craftsmen executing every step to exacting standards. The Soviets had apparently created a tank that was good enough, simple enough to mass produce, and protected by armor that German standard weapons could not defeat. "We need to test heavier weapons," Werner said. "Bring up the 88. The 88mm anti-aircraft gun had been used increasingly in an anti-tank role, with devastating effect against British and French armor. If any German weapon could defeat this Soviet armor, it would be the 88. The gun arrived that afternoon, towed by a heavy truck and positioned 500 meters from the target tank. The crew, experienced artillerymen who had served in France and North Africa, loaded an armor-piercing round and prepared to fire. Werner watched through field glasses. The gun fired with a deeper boom than the lighter weapons. The shell struck the T-34's frontal armor, and this time finally penetrated. The shell punched through the glacis plate, exiting through the rear of the tank in a shower of metal fragments. "Success," Colonel Guderian said with relief. But Werner was not smiling. "Colonel, do you understand what this means? We have just demonstrated that our standard anti-tank guns are ineffective against this Soviet design. The only weapon that can reliably defeat this armor is our 88mm gun, which is primarily an anti-aircraft weapon. We have 800 such guns in total production. The Soviets are producing more than 1,000 of these tanks every month." The silence that followed was profound. Colonel Guderian stared at the penetrated tank as if seeing it for the first time. "What do you recommend?" Werner walked to the tank, placed his hand on the cold steel. "We need to fundamentally reconsider our approach. This armor is not a miracle. It is simple, effective metallurgy combined with brilliant geometric design. The Soviets have created something we did not think possible. A tank that is simultaneously simple to manufacture and difficult to defeat. We must either develop new weapons capable of defeating this armor, or we must develop our own armor using similar principles." Over the following weeks, Werner's team conducted exhaustive testing. They examined every aspect of the T-34, the armor, the gun, the engine, the suspension, the tracks. Each element revealed the same philosophy: simplicity in service of effectiveness, manufacturing ease prioritized over refinement, adequate performance chosen over optimal complexity. The diesel engine, for example, used a simple fuel injection system that was less efficient than German designs, but far more reliable and easier to maintain. The Christie suspension provided excellent mobility across rough terrain, using a design that was mechanically straightforward. The wide tracks distributed weight effectively, giving the tank mobility in snow and mud, where German tanks with narrower tracks became immobilized. Vogel prepared a comprehensive technical report documenting their findings. Werner wrote a separate strategic assessment. Both documents reached the same conclusion. Germany was facing an opponent who had made different engineering choices, not inferior ones, and these choices were proving devastatingly effective. In November, Werner received orders to present his findings to a gathering of senior military and industrial officials in Berlin. He prepared his presentation with the same meticulous care he applied to his research, knowing that the reception would likely be hostile. The conference room was filled with generals, industrial magnates, and government officials. Werner stood at the podium with his charts and samples, facing an audience that expected him to explain how German engineering would triumph over Soviet primitiveness. "Gentlemen," he began, "I must report findings that contradict our previous assumptions about Soviet industrial and engineering capabilities." He described the testing, the armor composition, the ballistic performance. He showed photographs of German shells bouncing off Soviet armor. He presented the metallurgical data. He explained the production rate estimates. A general interrupted. "Are you suggesting that Soviet steel is superior to German steel?" "No, sir," Werner replied carefully. "I am suggesting that Soviet armor design is optimized for different priorities than German armor design, and for their purposes, it may be more effective. They have sacrificed finish quality, manufacturing precision, and crew comfort in exchange for protection, simplicity, and production speed." An industrial representative stood. "This is defeatist talk. German engineering is the finest in the world. We simply need to apply more resources, more precision, more quality control." Werner took a deep breath. "With respect, sir, that is exactly the wrong lesson to learn from this analysis. The Soviets are not trying to match our quality. They are not competing in precision. They are competing in effectiveness per unit of industrial effort, and by that measure, they may be defeating us." The room erupted in arguments. Some officials dismissed Werner's findings entirely. Others demanded immediate programs to develop superior German designs. A few, the most thoughtful ones, sat in silence, recognizing the strategic implications. Werner's report was officially filed and largely ignored, but copies circulated among designers and engineers. In January of 1942, Germany began development of a new tank design that incorporated lessons from the T-34, sloped armor, better weight distribution, improved mobility. This design would eventually become the Panther tank, one of Germany's most effective armored vehicles. But the Panther would not enter production until 1943 and would never be manufactured in numbers comparable to Soviet production rates. The Germans had learned the lessons from testing the T-34's armor, but learning and acting on those lessons within their industrial and doctrinal framework proved difficult. Werner continued his work at the testing facility throughout the conflict. He examined every new Soviet tank variant that was captured, improved T-34s with heavier armor and more powerful guns, heavy tanks with even thicker protection, self-propelled guns on modified tank chassis. Each design showed the same philosophy: effective simplicity over complex sophistication. In his private journal, Werner wrote extensive notes about the experience of testing that first captured T-34. He reflected on how his assumptions had been overturned, how his confidence in German superiority had been based on criteria that Soviet designers had simply chosen not to prioritize. One entry, dated March 1942, was particularly revealing. Werner wrote, "We have been asking the wrong question. We asked, how can we make the best tank? When we should have been asking, how can we make enough effective tanks?" The Soviets understood this distinction. They created a design that was good enough and made it in overwhelming numbers. In engineering school, we learned to optimize every parameter. The Soviets optimized the only parameter that matters: winning. Vogel, the young metallurgist, went on to become a leading figure in post-conflict materials science, always emphasizing the importance of appropriate technology over optimal technology, effectiveness over elegance. He never forgot the lesson of that October day, when Soviet armor defied every prediction. Richter spent his later years writing technical histories of armored warfare. His chapter on the T-34 testing was required reading for engineering students, a case study in how different design philosophies could lead to equally valid but fundamentally different solutions. Hoffman, the crystallographer, became obsessed with Soviet metallurgical techniques. After the conflict ended, he spent decades studying captured Soviet technical documents, trying to understand how they had achieved such effective results with what appeared to be simpler processes than German methods. He eventually concluded that the Soviets had simply been willing to accept wider tolerances in exchange for faster production, a trade-off that Germany's precision-focused culture could not easily make. The T-34 itself, the tank that had been tested so exhaustively in October 1941, was eventually scrapped, but not before it had been examined by hundreds of engineers, technicians, and military officials, each trying to understand how this crude-looking machine had proven so difficult to defeat. The impact of that testing day rippled through German military planning. Anti-tank gun development accelerated. Tank design philosophy shifted toward heavier armor and more powerful guns. Tactical doctrine evolved to emphasize supporting anti-tank weapons rather than relying solely on tank-versus-tank combat. But the fundamental strategic reality remained unchanged. The Soviets could produce tanks faster than Germany could defeat them. For every T-34 knocked out on the Eastern Front, 2 more rolled off Soviet production lines. The armor that had bounced German shells in October 1941 continued to protect Soviet crews through countless battles across thousands of kilometers of front line. Werner often reflected on the irony that the most important discovery of his career had been learning he was wrong. Wrong about Soviet capabilities, wrong about what constituted superior engineering, wrong about the metrics that mattered in industrial warfare. The shells bouncing off that Soviet armor had shattered more than just German confidence in their weaponry. They had shattered assumptions about technological superiority that ran deep in German culture. In the decades after the conflict, the T-34 became recognized as one of the most influential tank designs in history. More than 84,000 were manufactured, seeing service in conflicts around the world for decades. Its combination of firepower, protection, and mobility in a design simple enough for mass production became the template for generations of armored vehicles. But Werner always remembered it as the tank that taught him humility, the tank whose crude welds and rough finish had hidden sophisticated metallurgy, the tank whose simple angular shape had embodied a design philosophy that Germany, with all its engineering excellence, had failed to understand until too late. The testing facility outside Berlin was eventually destroyed in the final days of the conflict in Europe. Werner's laboratory, with its careful notes and meticulous test results, was reduced to rubble. But the lesson of that October day survived, transmitted through technical reports, engineering journals, and the memories of men who had witnessed shells bouncing off armor that should not have been able to resist them. In 1946, Werner was interviewed by Allied technical intelligence teams. They were cataloging German wartime research, trying to understand what the Germans had known and when they had known it. Werner showed them copies of his reports from October 1941, explaining how they had tested Soviet armor and discovered its effectiveness. An American engineer studying the reports asked the obvious question: if you knew in October 1941 that the T-34 was this effective, why didn't Germany adapt faster? Werner considered the question for a long moment before answering. Because knowing and understanding are different things. We knew the test results. We understood that Soviet armor was difficult to defeat, but we did not truly understand what that meant. We thought it was a problem of weapons development, that we needed better guns. We did not understand that it was a problem of industrial philosophy, that the Soviets had made fundamentally different choices about how to wage mechanized warfare. By the time we truly understood, it was too late to match their production capacity. The American made notes, nodded, moved on to other questions. But Werner's answer captured something essential about the experience of that October testing day and its aftermath. They had gathered data, performed analyses, written reports, but understanding had come slowly, resisted by assumptions and cultural frameworks that made it difficult to accept that German approaches might not be universally superior. The shells bouncing off Soviet armor had been trying to tell them something. It had taken far too long to truly listen. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II and check out the video on screen for another incredible tale from history. Until next time.